Hello students. In previous session we learnt about different states of matter. That is, we learnt about solid state of matter and liquid state of matter and some of the properties relative to solid state of matter and liquid state of matter. The first topic of today's session will be gaseous state of matter. First, let us look at some of the properties of gaseous state of matter. Gases do not have fixed shapes. Second one, gases have maximum ability to move around. That is, gases will have maximum ability to move. Next property, gases do not keep their volume and are highly compressible. Next property, gases are generally very light. The kinetic energy of the particles in the gaseous state is very high. Next property, gases exert pressure. And the last one, gases diffuse very rapidly. I repeat, gases do not have fixed shape. Gases will have maximum ability to move. Gases do not keep their volume and are highly compressible. Gases are generally very light. The kinetic energy of the particles in the gaseous state is very high. Gases exert pressure and gases diffuse very rapidly. First property, gases do not have fixed shape. They acquire the shape of the container in which they are filled or kept. You would have often come across a balloon seller with a variety of balloons hanging from a stick. They have different shapes, but all of them have air inside of it. This shows that the same air has acquired different shapes depending upon the nature and size of the balloon. So, gases do not have their own shape, but they acquire the shape of the container in which they are filled or placed. Next property, gases have maximum ability to move. Since the interparticle spaces are maximum in case of gaseous state, the attractive forces will be least. As a result of this, gases will be able to move maximum as compared to solid state of matter as well as liquid state of matter. So remember, interparticle spaces are maximum in case of gaseous state, so will be the attractive forces least. Hence, gases have maximum ability to move. Next property, gases do not keep their volume and are highly compressible. In gases, since the interparticle distance in the gaseous state are very large, they can be changed. That is, they can be increased or decreased by altering the pressure. If you apply the pressure, you can decrease that state of matter. Whereas if you release the pressure, if you decrease the pressure, you can let them free. That is, the particles will be able to move around. Whereas if you increase the pressure, you can compress them. This means that change in pressure can bring a change in volume, or we can say that gases do not keep their volume. Okay, let us consider a simple activity to understand this. All of us are quite familiar with cooking with gas cylinders. You would have observed them, which contains in it LPG, that is liquefied petroleum gas. It's a mixture of different gases such as propane, butane, and these are highly compressed, that they are in the form of liquefied, or that is, we are highly compressing them and making them liquid. By applying pressure on gases, you can compress them and make them as liquids. When the regulator is opened, the liquid escapes from the nozzle of the cylinder into a space where pressure is very less. I repeat, when the regulator is opened, the liquid escapes from the nozzle of the cylinder into a space where pressure is very less. As a result, there is sudden increase in volume and the liquid changes into gas. That is when we open the nozzle. As a result, there is sudden increase in volume and the liquid changes into gaseous form. The released gas gets mixed with oxygen from air and ignite when it burns. I repeat, the released gases get mixed with oxygen from air and they will be getting ignited when we burn them. From this observation, it's very clear that we can compress the gaseous form of matter into liquid. Hence, gases do not keep their volume and are highly compressible. Next property, gases are generally very light. As compared to the solids and liquids, gases are generally very light. Actually, the interparticle spaces are very large. As a result of this, the particles and gas are far separated, and the volume of a given mass of gas is quite large. The density of the gas is very small, and hence the gases are said to be light. I repeat, we know that density is given by mass by volume. The density of the gas will be very small. Hence, gases are said to be light. Next point, the kinetic energy of the particles in the gaseous state is very high. Among the three states of matter, the kinetic energy of the particles is maximum in case of gaseous state, and the interparticle forces are very weak. As a result, the particles of the molecules of a gas can move quite freely from one place to the other. This means that their translatory motion is very large and hence kinetic energy is very high. It can further increase when the temperature of the gas is increased. That is, by increasing the temperature value of a gas or gaseous state of matter, we can increase their kinetic energy, hence increase their motion. That is motion of particles. Hence remember, the kinetic energy of the particles in gaseous state is very high. Next property, gases exert pressure. Pressure of a gas is because of the hits which their particles record on the walls of a container. That is, when a gas is placed in a container, the particles of a gas are going to hit the wall. Since particles in a gas have high kinetic energy, they strike the walls of the container with more force. I repeat the point. Since particles in a gas have high kinetic energy, they strike the wall of the container with more force. As a result, they exert pressure. We know that pressure is equals to force upon area. That is, P is equals to F by A. P is pressure, F is force, and A is area. When these gas molecules strike the walls, they exert pressure. And please note that greater the number of hits recorded per unit area on the wall of the container, more will be the pressure of the gas. I repeat the point, greater will be the number of hits recorded per unit area of the wall of the container, more will be the pressure of the gas. So hence remember, gases exert pressure. Next property, gases diffuse very rapidly. Since the interparticle spaces are very large and interparticle forces are quite weak, the particles of one gas can readily move into empty spaces of one more gas. That is why the diffusion is maximum among gases. For example, the smell of the food, say we take fish, the smell of a food, particularly of fish being cooked in the kitchen, spreads all over our lobby and even in different rooms because of diffusion. The food particles with specific smell diffuse into the air. As a result, their smell can be felt even from a distance. Similarly, the fragrance of burning incense stick or agarbatti, what we call them as, spreads all over due to diffusion of smoke released from the incense sticks into air. So hence always remember, gases diffuse very rapidly. Next topic of discussion, change of state of matter. We will learn that the three states of matter differ with respect to interparticle species only. There are minimum in solid state and maximum in gaseous state of substance. I repeat, this interparticle species of matter are minimum in case of solid state, whereas maximum in case of gaseous state of matter. Now, let us try to find out whether these states of matter can be interchanged or not. The answer is yes. Say for example, if we keep some ice in a container, it melts after some time into water. If we place the container of water to heat, water vapors are noticed. In other words, we can say that one state of a substance can be converted into the other by changing interparticle spaces. So remember, whenever we talk about change of state of matter, it is very important to understand interparticle spaces are getting changed. They actually change interparticle force of attraction as well.